All right. All right, so here we go for today. We're going to be looking at the concept of power. And if we look at our definitions page, power is the amount of work done in a given period of time. Time will always be measured in seconds. So that's one of the things that you're always going to need to be mindful of, is that if you have time in another unit other than seconds, you have to convert them into seconds. And so when we start to look at then what we call the amount of work done in a given period of time, now remember the definition for work is the exertion of a force for a specific distance, or we can also say the force exerted for a given distance in a period of time. So that's what we're talking about now with power. And so really we're going to just be talking about now is how much work you're doing in a period of time. So when we look at our equations then for it, we've got our units here then. The units for power are the watts. The unit then for work still is joules, and the unit for time now is seconds. So remember that if you don't have it in seconds, if you've got minutes or hours, that you need to make conversions back to then seconds. So as we look then at our equation page here then, and that's one of the things that we should have out in front of us now, we're going to add some new equations into this. And so what we now have, so now what we have here is, here's power, there we go. So power is going to equal work divided by time. The units for power is a capital W for watts. Just like the units for work is a capital J, power is a capital W for watt. Now we have a new equation for work, and work is going to equal power times time, and again the units for that will still be a joule. And we now have then a new equation then for time, and time will be measured in then time will be equal to work divided by power. Units for that will be seconds. So if we take a look at now the partner problems for this page for power here, this is the page where now this starts to get really complicated with things. And you're going to probably find the hardest problem is going to be that we're going to be doing this year is going to be here with power. This is where you're going to continually have to kind of work forward to work backwards on things. And that's one of the things as I've kind of talked with you about as we kind of take a look at some of these things. So let's try to find an example of that we can kind of take a look at here. So if you take a look at this one here, number 4, a box of snowshoes was delivered to a base camp of mountain climbers on top of Mount Everest. The mass of the box is 75 kilograms. That's a mass. The gravitational acceleration on top of Everest is 9.75 meters per second squared. That's your G. If a rope is attached to the box and 50 watts of power, there's your power, is used to pull the box up to the climbers in 30 seconds, how far did the box have to be pulled up? Well, the first place that we're going to start in this process, how far did the box have to be pulled up? Okay, so here's our initial equation. Distance is work divided by force. Now the problem is that you don't necessarily have either one of those. And so you're going to have to work backwards again to work forwards. And so one of the first things that we can do then is to solve then for work. Well, work is going to be power times time. Well, we have the power, which was 50 watts of power, and we have time, which was 30 seconds. So we now have then power of, or work, excuse me, of 1,500 joules. Now we can then also find the force, and then we'll have to do this then third, excuse me, and that will be then the mass times gravity. We have the mass and we have the gravity. So we now then end up having our force then, which is then 731.25. Now if we go back to then our initial equation then, distance is work divided by force, we now have 1,500 divided by 731.25, with our answer being 2.05 meters. So it's again one of those examples where you've got to be able to work backwards to work forwards with it. As we take a look at these ones, the real kind of hard one here is in question number 7. This one here is probably the hardest one that you're going to need. This is one of the things that I would draw a picture to help with. And I would also then create a chart as well, which labels then what information you have and what information you're looking to find. If you can do that with those problems, you are all set with number 7. If you can do number 7, you can do just about any problem that we have in what we've done and what we will be doing coming up next. That's kind of really that A problem. If you can get 7, you're going to get everything else. So if you just want to challenge yourself, go ahead and start with number 7. And if you can do 7, you've got all the rest of them there then. Otherwise, why don't you go ahead and then try taking a look at some of the partner problems then for power here, these 1 through 12, and write down or jot down in notes on the side what questions that you might have with that, so that when we come back then next week, we're probably going to be looking at work and power. I'm going to say probably, I'm hoping Wednesday of next week that we can then start that process in. When we start looking at next week, we're going to be coming back to school on Tuesday. We're going to finish up our bridges on Tuesday, and I'm hoping that we might actually even start the competition then on Tuesday. And then that would leave us then Wednesday, Thursday then to be able to do work and power, and then the quiz then on Friday, which would be force through power then. So that's one of the things that you might want to be mindful of then. And let's just kind of make sure that we get that down then. So then quiz on Friday, I think that's November, I want to say it's November 1st. I'm not quite sure, but I'm hoping that is. Then quiz, and that would be then force through power. Okay, so make sure that you come next week with any questions that you have about that, and also you can email me over the weekend too if you need to. Thanks a lot.